so let's just do it. How about, I'm going to do some fractions. All right, if I asked you to solve this equation, we talked about different options. You guys usually opted to just get rid of all of the fractions. If you want to get rid of these fractions, look at your denominators. We have a 2, 4, and 3. What could I multiply by that would cancel all of those? 12. So you are taking each term here times 12. Now 12 divided by 3 is 4. So we have 4 times the 2x plus 1. 12 divided by 4 times the x minus 1. And 12 divided by 2 is 6. So now if we solve, we get 8x plus 4 plus 3x minus 3 equals 78. Add like terms. Subtract a 1. Divide by 11. And we get x equals 7. Nice thing about these, we can always check them just by plugging it back into the original. Okay. Everybody with me on this one? Let's say I gave you this problem. Okay, when we were solving these linear equations, we can have fractions and decimals in here. So you guys have a calculator. Having a fraction in a problem is nothing to be scared of. We can just solve this. What would I need to do with my 1/2? Distribute. So that's a 1/2 x minus 3 times a half. If you need to, use your calculator on these. Just keep it in fraction form. Don't change it to decimals that you have to round. 2/3 times 2x. 2/3 times -5. Okay, if I want to add like terms, okay, if you need to, use your calculator. 5/12 minus 10/3. Put it in fraction form, tell me what we get.
35, -35/12.
Okay, I need my x's on one side, so I'm going to subtract over this 4/3 x. So 1/2 minus 4/3. What do you get? Okay, add over my 3/2. -35 over 12 plus 3/2.
-17/12.
And then what do we need to do?
Divide by -5/6.
When you put this in the calculator, make sure you put the top and bottom in parentheses. And we get So don't get scared if you see a fraction or decimal in here. Same process. You're just solving an equation. You have that calculator. There's nothing to be afraid of there. We also talked about classifying these. We use the terms identity, contradiction, and conditional. Both of these we solved and we got an answer. What do we call that?
Conditional.
They're true under the condition x equals a certain number. Okay, let's say I gave you this one. What would we do?
Distribute it into one.
Hold on, I wrote this problem down wrong. I meant for that to be a 5x right there. I apologize. Okay, if we combine like terms, we get negative 9 minus 4x here. If I add my 4x to each side, those cancel, and we get 5 equals negative 9. What does that mean? Right. I do want you to write the solution, which is no solution, and tell me contradiction. So on those, I will ask for the solution, and then I'll say I label it as an identity, contradiction, or conditional. I'll give you the word choices. Last one to review from this section. Let's say I gave you this problem. What would you do first?
Distribute on the left.
So we get 3x plus 6. Over here, that's like a negative 5. So if I distribute the negative 5, I have a negative 5x and negative 10. Add like terms. I add my 2x. Those cancel, so we have negative 4 equals negative 4. What does that mean? All real numbers. Right. Is this okay with everybody? So that was the section 5. Section 6, you're going to have a handout to review today, but I thought I might do at least a couple problems just to kind of get us thinking back along those lines. So this one, I have the length of a rectangular label. What should I do?
Draw a rectangle.
Okay, the length is 3 centimeters less than twice the width. Do we know what the width is?
No.
So I'm going to call that x. So this is 3 less than. Less than means
3
minus 3. The less than flips the order. Twice the width would be x. I did one Friday that I think I did a triangle example. When you go to do perimeter, it doesn't matter what shape it is. How do you find your perimeter? Add up all your sides. So you have a couple options. You can either go around your picture and just write out every side. You could remember that in a rectangle it's 2 times the length plus 2 times the width. So either way, as long as you've accounted for all 4 sides. So then we just solve this. And so then, what do we have to do at the end? Always write a sentence, so the dimensions are 10 centimeters by, to get the other side, if I plug in my 10, I get 20 minus 3, so 17 centimeters. Those were our geometry problems. Then we got into those mixture problems. So we did the mixture, we did the interest, but our strategy was pretty much the same for those. We have to plug all of our information into a table to help organize it. So let's just try one of those, and that might be the end of my review for today. Then I'll let you guys work so you can ask questions over anything specific you need. Alright, how much water should be added to 20 liters of an 18% acid to reduce the concentration to 15% acid? So we have a mixture. We have a lot of different information here. So we go to the table. Really, the only difference in these and the interest problems is the formula you put across the top. For these, we did the amount times the concentration equals the amount pure. What did we do for interest?
Principal times rate times time equals interest.
Perfect. Okay. So the labels over here, you can call them whatever you want. First, second, total if you want, or you can use the percents here. We have our columns. So you're going back and rereading the problem, and basically every time you find a number, you have to figure out where it goes. It says how much water. When I'm talking about the how much, I'm talking about the amount. So the first thing here is water. I don't know how much, so that would be my X. If you're talking about water, what is the concentration of water? 0. We had pure and we had water. Water has nothing else in it, so its concentration is 0. If I said it was pure acid, that would be 100%, so we would use the 1. Should be added to 20 liters, so my amount is 20, of an 18% acid, so concentration is 1.18. To reduce the concentration to 15%, so my total is 0.15. What would I put here? So then you just multiply across, so x times 0 is 0, 20 times the 0.18, 0.15 times the 20 plus x. And how do we write our equations from here?
E equal to 0.
So if we multiply 0.18 times 20, 3.6, 0.15 times 20 is 3. Subtract over your 3, divide by 0.15, and we get 4. So the question was how much water? It must be 4 liters of water. Any questions on that? So the quiz will cover the section 1.5 examples I did at the beginning, solving your equations, identifying the identity, contradiction, conditional, and then the word problems. So the word problems, there is a handout that you guys, a lot of you started on Friday. It's the 1.6 review problems. on Classroom, and you've got the next half hour to work on that and ask for help when you need it.